Now let's look at compounds that contain polyatomic ions. Polyatomic ions are ions that are composed of two or more elements. For example, Cn-1 is called a cyanide ion. It's considered a polyatomic ion. And many more examples that I will show you. So, naming compounds that contain polyatomic ions is very similar to naming ionic compounds. So you start with the name of the metal followed by the name of the polyatomic anion. And if your metal is a transition metal, you gotta name the you gotta mention the charge of the transition metal. Now, for polyatomic ion, you gotta memorize the name of the polyatomic ions, their charge, and their formulas. So on this table, you see some common polyatomic ions. So for these polyatomic ions, please look at the formula, their name, and charge. You need to memorize the name of the polyatomic ion, their formula, and their charges. Now, how the naming goes, the rules are a little bit different when it gets to polyatomic ions. So most of the polyatomic ions that you guys will see are oxyanions, and those are the polyatomic ions that contain oxygen. Now, for naming these, if you have the most number of oxygens possible, the name of the polyatomic ion ends with 8. And if you have one less oxygen, it ends with "ite." So for example, most number of oxygens possible for sulfur is 4. So if you have SO4 2 negative, this becomes a sulfate ion. If you have one oxygen less than sulfate, let's say 2 oxygen, this becomes a sulfite. Another example could be nitrate and nitrite. The most number of oxygens nitrogen can have is 3. So if you have 3 oxygens, this becomes a nitrate ion. So 1 oxygen less, and O2 negative 1 becomes a nitrite ion. Now, why sulfur can have a maximum of 4 oxygen and nitrogen maximum of 3 oxygens really depends on their Lewis structure. So for now, just memorize the polyatomic ions, their formula, their charge, and their name. Now, for some polyatomic ions or oxyanions, their naming is a little bit different depending on how many oxygens we have. So we're going to use prefixes as per and hypo for naming these compounds. So not all the polyatomic ions will do this, will form anions that contains per and hypo, but chlorine is one of those that does this. So here is how we name these compounds. So most number of oxygens chlorine can have is 3. 3 is called a chlorate ion. Now 1 oxygen less than chlorate, which is 2 oxygen, becomes chlorite. 1 oxygen less than chlorite, now 1 becomes a hypochlorite. So we take chlorate as a base. 1 oxygen more than chlorate, you get perchlorate. 1 oxygen less than chlorate is going to be the chlorite ion, and 1 oxygen less than chlorite becomes a hypochlorite. So the only other ions that the only other oxyanions in this format are going to be with bromine and iodine. So these are the two that you need to know for now. So you get bromate, perbromate, and hypobromite. So iodate, iodide, periodide, and hypoiodide. Now these oxyanions, so oxyanions are polyatomic ions that contain oxygen and they have a negative charge. If they combine with a hydrogen, they form oxyacids. So oxyacids are basically hydrogens plus oxyanions. Now the rule for naming oxyacids is that if the oxyanion's name ends with 8, so if the name of the oxyanion ends with 8, you're gonna add the ic for the name of the acid. So chlorate becomes chloric acid. Now if the name of the oxyanion ends with ite, you add the us here for the acid. So chloride becomes chlorous acid. Then you can have hypochlorous and perchloric acid as well. So for example, SO4 negative is a sulfate ion. Now if we combine this with hydrogen, H2SO4 becomes sulfuric acid. Another example, NO3 -1 is a nitrate ion. Now if it combines with a hydrogen, HNO3 is called nitric acid. SO3 -2 is called a sulfite ion. Now, if this adds with hydrogen, it forms the oxyacid, and this is called sulfurous acid. Same thing with nitrite. NO2 -1 is the nitrite ion. Now when it forms acid, it becomes nitrous acid. So memorize the name of the polyatomic ion, their formula, and also their charge. So for polyatomic ions, memorize name, so for polyatomic ions, we want to memorize their name, formula, and charge. For now, you really have to memorize them until we look at Lewis's structure and learn how many oxygens for each one of these, and we get more information about their charges. But for now, the only way is memorizing the name, formula, and charge of the polyatomic ions. Now let's look at a couple of examples. You want to name this following compound. So sodium is a metal, nitrate is an anion, so it is an ionic compound which is composed of a metal and oxyanion. So it's composed of sodium ion and a nitrate ion. So in order to name this, this is called sodium nitrate. Now in terms of writing the formula for these compounds that contain polyatomic ions is the same as ionic compound. So sodium is in group 1A, always positive 1 charge. Nitrate, we know that the charge is -1. So in order to write the formula, you first write the metal followed by the anion here, which happens to be the oxyanion. Now the charge of sodium is +1, nitrate is -1, so you need one of each. Now one thing to keep in mind and pay attention to is that when I say NO3 -1, I'm looking at a nitrate ion as a unit. So this negative charge is on the entire nitrate ion, not just on the nitrogen, not just on the oxygen. So you can also think about it as nitrate as a unit has a -1 charge. So NO3 -1 as 1 unit is called a nitrate ion. If you change the number of nitrogen, oxygens, the charge, this is not going to be a nitrate anymore. So let's say you want to write the formula of compound that is composed of magnesium ion, and nitrate ion. So we want to write the formula and we want to name this. So to write the formula just like any other ionic compound, you first write your metal, which is magnesium, your cation, followed by the anion, which happens to be the nitrate ion, which is a polyatomic ion. Now, second step is balancing the charge. Make sure that our ionic compound is basically neutral. The net charge is 0. Now, magnesium is a 2 positive, nitrate is a -1. In order to balance the charge, you would need to have 2 nitrate ions to balance the +2 charge of magnesium. How do I say 2 nitrate? You put a parenthesis and you give it a subscript. So polyatomic ions, we treat them as units. So if it needs to have a subscript, you put them in parentheses and you give them the subscript. Let's look at another example. Let's write the formula of compound that's composed of barium and phosphate. So to write the formula barium metal phosphate oxyanion, so to write the formula, first of all, we write barium and then phosphate. Now, second step is balancing the charges by using subscripts. So I'm going to swap the charges between barium and phosphate. I'm going to give barium a 3 and phosphate 2. Now to double check and make sure that this formula is correct, here is how you check. So you have 3 barium, each one of them positive 2, plus you have 2 phosphate ion, each one of them negative 3. This is a positive 6, this is a negative 6, which equals to 0. So this is a correct formula of barium phosphate. Let's do more examples. Oops. So you want to name this compound KCN. So KCN is composed of potassium ion and cyanide ion. And it's called potassium cyanide. Now, in terms of the formula and how the formula is written, potassium is positive 1, cyanide is negative 1. So to write the formula, you first write sodium and then cyanide. Now, potassium is positive 1, cyanide negative 1, they cancel out. So you want 1 potassium, 1 cyanide, and it becomes potassium cyanide. Let's look at another example. You want to name this compound. So good way of approaching this is first of all figuring out what the charges of cations and anions are here. So lithium, and let's say you don't know the charge of ClO2, the oxyanion here. So lithium is in group 1A. What would you expect the charge of lithium to be? Plus 1. So now if lithium is positive 1, it means that ClO2 is a negative 1. Now when you put them together, you want 1 of each in order to balance the charge. Now ClO2 negative 1 is called a chloride. So to name this, this is going to be lithium chloride. Let's look at another example. NH4I. So the charge of ammonium ion is positive 1. Let's say I don't remember that it's positive 1. I can still figure it out. Iodide, group 7A, is always negative 1. So if iodide is negative 1, it means that the ammonium ion has to be a positive 1. Now the name of this compound is ammonium iodide. So once you memorize name, formula, and charges of polyatomic ions, naming them is really not that hard. Now let's look at some oxyacids. So oxyacids, when you have hydrogen and oxyanion, this becomes an oxyacids. We briefly talked about this. If the name of the oxyanion ends with 8, you change that 8 to ic for naming the acid, sulfate, sulfuric. And if the oxyanion name ends with ite, you change that to us. Now remember, ic was for when you have most number of oxygen. Us is when you have one less oxygen. So for example, this compound H2SO4 is called sulfuric acid because SO4 negative 2 is sulfate. So this becomes sulfuric acid. Why is it an acid? Because you have hydrogen and oxyanion. So it becomes an acid and it's a sulfuric acid. Now let's see what ions exist in sulfuric acid. So what's the charge of hydrogen ion? Positive 1, very good. Hydrogen is in group 1, so the charge of hydrogen is always positive 1. And you also have sulfate ion, which is a 2 negative. Now, in order to write the formula of sulfuric acid, you put hydrogen and SO4. So SO4 has negative 2 charges, hydrogen plus 1. To balance the charge, you're going to need to have 2 hydrogens here. So even for the acids, we're looking at the charges and we're balancing the charge. That's why the number of hydrogens for each oxyacid is different. Number of hydrogens really depends on the charge of the oxyanion. So let's look at another example here, HNO2. This is composed of hydrogen ion and a nitrite ion. So since this is an oxyacid, this is called a nitrous acid. Now, for naming the acids, we can put this flowchart together. So acids that begins with, those are the compounds that begins with hydrogens. So if you have a hydrogen and oxyacid, you look at the ending for the oxyanion. If it ends with ate, the name of acid ends with ik. If it ends with ite, the name of the acid ends with us. And then for chlorine, bromine, iodine, we looked at the hypo and per. So we're gonna have to add those to the name of the acid too. So hypochloric, perchloric, or hypochlorite.